Cool, awesome. Welcome back everyone from the break. So we're going to be talking about how you can cut your cluster costs. And basically in this session we'll be giving you an overview of some of the innovations we've made in the past few months on giving our customers visibility into their EKS cluster costs and how customers can use the data and information to reduce their Kubernetes spend and optimize their EKS costs. My name is Vipin Mohan. I am a principal product manager in the AWS Kubernetes team at Amazon. And before the break, Sai said we have a special guest, so here he is.
Hi, my name is Ajay Tripathi. I'm co-founder and CTO at KubeCost.
Cool. So let's jump in. And before we start, I want to give a shout out and a huge thank you to a bunch of folks who helped with this presentation and are also instrumental in some of the projects that we're going to be talking about on both the AWS side and the KubeCost side. So in terms of our agenda, we'll start off by understanding what is the customer problem with Kubernetes cost management. What are the common challenges that customers face? And then we'll talk about some of the approaches that we have built to help our customers get better visibility into the Kubernetes costs, as well as how they can address these pain points. We'll have some demos along the way, and we'll have some time for Q&A towards the end as well. So to set some background, let's start by understanding who is the customer for understanding, or who has the pain point or challenges around Kubernetes costs. So if you look at it in organizations, typically there's the Kubernetes cluster administrator, and many of our customers run shared EKS clusters. What I mean by shared EKS clusters is that there could be multiple application development teams who are using an EKS cluster for their respective applications. And they may be using abstractions such as namespace or Kubernetes labels to determine which parts of the cluster belong to whom. So the job of the Kubernetes cluster administrator is to bring up these clusters, create these clusters, and vend these clusters to these application development teams so that they can go on and innovate on their business. So that's the Kubernetes cluster administrator. The finance leaders are typically the folks who roll up to the CFO organization within a company, and they're focused on budgeting and making sure that costs and expenses are under check. So those are the two main customers that we want to address challenges for. And if you look at the customer challenges for the Kubernetes cluster administrator, their main goal is to allocate costs back to the appropriate application development teams. And the reason they want to do that is to make sure there's some kind of visibility into each development team for how much cost or spend they are driving for the infrastructure business, or they may want to drive accountability in some cases. Sometimes there's a chargeback mechanism in place wherein there's a dollar transfer that happens between business units within a company, and if cluster administrators are not able to accurately allocate these costs, what happens is that there is no appropriate owner for a certain portion of the cost, and it either or incorrectly ends up in the platform IT team's budget, or it does not get allocated at all. If you look at the finance leaders within an organization, they want to accurately forecast and provide reports for leadership within the company on how much spend is being driven by different teams within the company. And effectively, not having the ability to, or the visibility into these costs results in uncertainty for these finance leaders, and it slows down the business innovation for our customers. So those are the challenges. And what customers have been doing until now is to use some kind of a manual approach. That could be a spreadsheet, for example, wherein they manually aggregate costs and then try to allocate it. But the problems with that are that it may not be always accurate, because customers sometimes have private pricing agreements or discounts that need to be applied. So those may not be accounted for accurately. Of course, manual efforts and spreadsheets are cumbersome to maintain. There's also the other option that customers sometimes choose is to use third-party software, and that results in increased license costs, time for negotiating those contracts, support costs associated with that, and effectively increasing the total cost of ownership for our customers. So what we decided to do was to take different approaches to address the customer problem with regard to cost management. But in this session today, we want you to walk away with 3 things that you can have in your toolkit to get better visibility into your EKS costs, as well as to optimize your EKS usage and costs. The first one we'll talk about is cost allocation tags. So a lot of our customers, like I mentioned, they have shared EKS clusters, or sometimes they have multiple EKS clusters. And the reason they do that is to get better resiliency or for a better security posture. Now, until we announced this capability, what customers told us was that they get a single line item per region for their EC2 spend. So when they look at their AWS bill, they get a lumped EC2 costs, and they were not able to determine how much of that EC2 cost was actually attributed to EKS and which EKS cluster, if they have multiple EKS clusters running, and how much was that non-EKS or Kubernetes related costs. So we announced cost allocation tagging earlier this year. And essentially what we're doing is when you have a EKS cluster and when you have worker nodes that participate or join that cluster, we automatically apply an AWS generated tag. So the key value for the tag is AWS :EKS cluster name. And that gets automatically applied regardless of how you add worker nodes to your cluster. Now, that could be from managed node groups that you use for your EKS cluster, or you could be using Karpenter to provision some of your nodes. We'll talk about Karpenter as well. Or you could be doing it manually using Amazon EC2. Regardless of how you add clusters, or how you add nodes to your cluster, these tags automatically get applied. And once you have these tags, you can then use these tags to break down your costs in the billing dashboard and in Cost Explorer. So that's about cost allocation tags. And we'll do a quick walkthrough of the console to actually see how this works. So if you go in here, so right now I'm in my EKS console. I have a cluster. The name is EKS cluster August 2022. And right now it's running a Kubernetes version 1.22. And if I go into the compute tab within my cluster, you can see that it has two nodes that are running. They're both M5 large instances, and they're part of a managed node group. Next, if I move into my EC2 console, so you'll be able to see that those 2 nodes show up that are part of my EKS cluster. And let's select one of those nodes. And if you look into the tags section of your instances, so you'll be able to see all of the tags that are being assigned to this instance. So if I move on to page 2, you'll be able to move on. You can see that the AWS :EKS cluster name key, and the value is the name of my EKS cluster. So that's automatically assigned to all of my worker nodes that are in my EKS cluster. So now that the pre-work has been done, so yeah, maybe I need to move on. Next slide. All right. So now you have assigned the tags to the instance. So let's see how you can actually use these tags in your billing dashboard. So we want to switch to the billing dashboard within your AWS account, and you need to do 2 things. One is to activate the tags. So you'd go into the cost allocation tags, and you can see that there's user defined tags and AWS generated tags. So the tags that we apply are considered AWS generated, and they do not count towards your tag limit. There's a 50 tag limit, if I remember correctly, for how many tags you can associate with a resource. So these tags do not count towards that limit. And you can see that you need to activate the tag. I activated this beforehand because it takes 24 hours from the time you activate a tag for it to actually show up on your dashboard. So once you've done that, you can go on to Cost Explorer, where you can actually graphically visualize your spend. And within Cost Explorer, let's do a daily cost for the month of September, say. And once you do that, you'll be able to see the cost for the month of September, and you can group by the tags. So what you're seeing here is that the green portion of the bar graph basically tells you how much of your EC2 spend is coming from EKS, and the blue or the purple portion is basically non-EKS related costs. And the reason you only see it for like half the month is because I activated the tag sometime around September 13th. And prior to that, I had not activated the tags, which is why you don't see the difference. So basically, this is how you will get better visibility into your EKS costs, and how much of your EC2 spend is being driven by EKS. And if you have more than one cluster, you're going to see like breakdown by cluster. All right, so that was number one, cost allocation tags. Hopefully that is useful. The next thing we want to talk about is Karpenter. So Karpenter is an open source, flexible, and highly performant cluster autoscaler. It works in tandem with the Kube scheduler and with your compute engine, such as Amazon EC2. And Karpenter is fully open source, and you can use it with any upstream Kubernetes cluster, not just EKS. So you could use it with either your clusters running in other clouds or within your on-premises environments as well. And it basically the main goal of Karpenter is to dynamically right size or pick the right size instances for scheduling your pods. And one of the things that we'll talk about in detail today is about how you can use Karpenter to lower your costs by consolidating pods onto different EC2 onto different instances. And with EKS, you can get support for Karpenter running in your clusters. And before I jump into the demo, I do want to touch upon Graviton. So AWS Graviton is Amazon's custom silicon. It's built on 64-bit Neoverse architecture, and it's based on ARM architecture. And with ARM, with Graviton on EKS, you get end-to-end multi-architecture support. What I mean by that is, you can store your container images, multi-architecture container images in your ECR repository. And then you can pull those images directly from ECR into your EKS cluster and deploy them as pods in your EKS cluster. And you can also take advantage of multi-architecture managed node groups. So you can have a managed node group with some instances with EKS with x86 and some running Graviton instances. And the main value add from today's discussion is around the price performance that you get with using Graviton. So if studies have shown that Graviton with EKS gives you up to 20% lower costs and 40% higher performance as compared to equivalent or similar x86 instances. So we'll take a look at how Karpenter works, but just to give you a background. So Karpenter uses something called a provisioner, which is a custom resource definition, and we'll walk through what this provisioner looks like. So I have a provisioner that I've created in my cluster, and if you walk through that, it's basically a YAML for a CRD, and we call it the kind is provisioner. And if you scroll down, there's something called the weight. So the weight basically tells you you can have multiple provisioners running in your cluster, and Karpenter will pick the one with the highest weight. And for some reason, if that doesn't work out, it would go on to the next lower weight and so on. And in this case, we've enabled consolidation to be true. So that's what will actually give us the cost benefit. There's also an inbuilt cost safeguard, wherein you can set a limit for the number of resources that you are provisioning with Karpenter. So in this case, I'm saying not more than 5,000 CPUs, no matter what, in this cluster. And one thing to note is that all of this is cloud provider agnostic. We'll go to the provider ref in a second, but let's walk through the instance family. So think of what you're setting here as primarily a set of constraints that are giving Karpenter, using which it will provision instances for you. So if you go into the instance family, I'm saying that I do not want any instances that are an A1, C1, C3, or C4. I've also set the instance CPU to be less than 33. So I want instances which are 32 CPUs or less. Oops, what just happened? All right, so we're back. And then we have the instance CPU, we just talked about it. We have the capacity type. The capacity type is where you say on-demand or spot. For this demo, I'll just use an on-demand instance. And lastly, we have the architecture that you can specify. It could be an AMD 64 or ARM. So in this case, let's change that to an ARM 64 instance. And Just know that we've modified the YAML, but we've not yet applied it, and I'll tell you why we did that. The next one is, like I mentioned, the provisioner talks about, gives you all information that is cloud provider agnostic, but you still need to specify, where some constraint or information for where Karpenter can provision these instances. So that is defined in the AWS node template. And if you go in there, you specify the subnet selector as well as the security group selector within which you would have Karpenter specify or bring up these instances for you. So that's what you specify in the AWS node template, and this is what was referenced as the provider ref in the provisioner that you saw. So this is on the node template, and we just applied do a kubectl apply of the node template so that it gets applied. So next, let's go in. Let me play this. Got it. So we've set up the provisioner and the node template now. Next, let's do some playing around. So we'll create a deployment. So in this case, I have a test deployment. It's called Inflate, and it's running the Kubernetes pause container. So let's do an apply of that deployment so that you create the deployment. And let's scale up that deployment, the number of replicas for the deployment to 60 replicas. So we'll do that. Great. So as soon as you scale that number of replicas up, you can start seeing that in the bottom window, Karpenter has immediately recognized that, yes, I have a new deployment that is being scaled up, and it's spinning up a C6A 4x large instance. So this is an x86 instance, and the reason it's picking up x86 is because we did not apply the changes that we made to the provisioner. So that will happen in the future. So what's happening is that it's spinning up a C6A instance. It's 4x large. It's telling me that it's going to cost me 61 cents per hour. And the time that you see on the far right is essentially the time it takes for the instance to come up. And right away, Karpenter is telling you that this instance is at 95.2% utilization, which is pretty good. So it's found the right size instance for for scheduling all of these 60 pods, and it's giving you the best price performance that it has at its disposal. So soon this instance will be up, and I'll just speed it up. So now it's ready, and you can see that Karpenter is starting to, or rather Kubernetes is starting to schedule these pods. And if I just speed this through a little bit, so you can see that all of the 60 pods are now running, and I'll do a kubectl get deployment. You can see, there's 60 of 60 pods. All of them are running on that particular instance. So that's great. So what we did right now was we created a deployment, we scaled it up, and Karpenter helped schedule it on the right size instance with the highest utilization. So what if I scale down my my replicas? Like in production, if I bring down my if my traffic goes down for some reason, what happens? Let's go through that. All right. So here we are. So we got all of those replicas running, and first thing we'll do is to apply that provisioner, because you remember we made that change from AMD 64 to ARM. So let's go ahead and apply that. So we'll do a kubectl apply. And that's now been configured in your cluster. And let's now scale down the number of replicas and see what happens. So from 60, we'll do a kubectl scale deployment, bring it down to let's say 5 replicas in this case. So now what's happening is, immediately the number of replicas has gone down. So it's still running on the C6A instance. So one thing to keep in mind is that your pods are still running, so your application is still active. And soon Karpenter will recognize that if you go in, it'll say that, hey, this is probably too big of an instance for me to be running just 5 pods. And what it's going to do is that it's going to bring up a T4G instance. So a few things to note here while this comes up is G is Graviton, so it's bringing up a Graviton instance. And second is that it's a small instance, and you can immediately see the price difference. So you were paying 61 cents an hour, but now with T4G small, you're paying 2 cents an hour for this instance. So it's bringing up that instance, and all the while your application is still up and running. So it's still up and running. And if I scroll down a little bit, just speed this up. So what will happen is that as soon as this T4G instance is ready, it should happen in a few seconds. It's ready now, and what Karpenter is going to do is to start scheduling, all of those pods over to the T4G instance, and it brought down the the C4A instance. So right now it's a 71% utilization, and it's the right size in terms of like price performance for running this particular application. I think that was. Yeah, you can do a kubectl get deployment inflate, and it will show you that all 5 of your pods are ready. So that was about Karpenter. So we saw how you could create a Karpenter provisioner. You can use it to schedule the right size instances, and all of this is done like behind the scenes without any additional effort needed from your side. All you do is you give Karpenter a set of constraints, and it operates within those constraints. So one of the things I want to call out is we have a customer who's actually using Karpenter in provision in production. So Bharti Airtel is a telecom company in India, and they have something called the Wink Studio platform. It's an audio streaming platform for like independent artists. So they create content and put it on this platform, and on average they stream about 1 terabyte of data per minute. But what happens is that, like as with any, like let's say a new song comes on and like there's a huge spike, which can be from like 2x to 4x at any given point of time, they need to be able to cater to their end customer needs so that, there's no disruption in the end customer experience. So they're using Karpenter in production, and for like almost 90% of their EKS worker nodes. And so they've seen like 47% cost reduction with using Spot instances. So in our demo today, we used on demand, but you can also use Spot if you want to like get better, even better price performance, or price rather. And they were able to reduce their time to scale from 2 minutes to 40 seconds. Scale up, and time to scale down was brought down from like 1 minute to 20 seconds. So they've been using successfully, in production, and they've been using it for a lot of like spiky workloads. So that's something I wanted to call out. And so we covered cost allocation tags, and we've covered Karpenter. And with these, like you're able to like get better visibility and better control of your, out of cluster costs, node level costs. So I'll hand it off to Ajay to talk about, OpenCost and KubeCost, which we'll talk about like in cluster costs.
Yeah, is it, well, I'll use your slides, I think, so just this button here?
Yeah.
Okay. We'll figure it out. Okay. Hey, everyone. Good morning. Want to talk a little bit about KubeCost and OpenCost, and starting with kind of back in 2019, when we were first building OpenCost, and as enterprise was adopting Kubernetes, we saw teams just increasingly struggle with day 2 operations, right? So we were going from a world where every team would have individual VMs, be very simple. I mean, not simple to provision, right? Like, anybody remember filing a ticket to spin up a couple of VMs for your team to deploy software on? Well, those days are gone, thankfully, with Kubernetes. But by the same token, you can just hit a button, kubectl scale up to 100 or 600 pods or whatever Vipin was showing, and really explode your cluster costs. So as these abstractions have been created, they're very powerful, but also need governance and management, right? So that's why we started building OpenCost and KubeCost. So people wanted to see and understand breakdowns of costs by namespace, pod, service, deployment, as well as schemas that they've already been using with labels and things like that. They want this to be transparent and fair, right, for how teams are getting billed across their infrastructure. They want to be able to set budgets, alerts, and generate basically profit and loss statements for infrastructure. And they want it to be accurate, right? They want it to actually reflect what people are, or what they're paying Amazon, for their network costs, for the actual nodes, and things like that. So our solution was to, have a community-built specification for how to do chargeback on these nodes and on the workloads running on these nodes, rather, as well as provide software implementation for that. So who's contributing to OpenCost? Practitioners like Adobe, cloud providers like AWS, KubeCost, which is where I work, is kind of leading the effort as the company behind it, and we are a CNCF sandbox project now. So what does OpenCost provide? I think really key here is just real-time visibility and allocation. So quickly understanding the data, the cost data as it streams in, and giving teams the ability to respond to that. Monitoring the costs by any sort of dimension that Kubernetes provides, as well as user-specified dimensions in labels and annotations. Native support for sharing resources, like, for example, kube system, you may want to charge that back to all of the tenants in the cluster, not just the DevOps team, as well as the allocation of costs without tagging, right? So when you don't tag or label or annotate, things like namespace, service deployment, et cetera, still have a lot of meaning. What does KubeCost provide on top of that in partnership with EKS? Well, we've got penny accurate with costs with integrations with the cost and usage report. That includes things like enterprise discounts, reserved instances, savings plans, et cetera. SSO and SAML so that teams can view just costs for their specific resources in case that's sensitive. Monitoring, alerting budgets, as well as cost optimizations and recommendations at the workload level, and a little bit at the cluster and VM level, in combination with Karpenter and the cluster autoscaler and other tools like that. Okay, so I think the best way to just look at this is to do a demo of where I will kind of explain some of the ideas behind cost allocation and governance, as well as take you through like what a workflow of a developer using KubeCost might look like. Okay, so here we can see cost at the top level just by cluster in AWS. For other views, we can also see multi-cluster here, but we'll kind of go through the AWS demo first. You can see cost by cluster, and I'll just point out, and it's broken down into subcategories like CPU, GPU, RAM, persistent volume, network traffic, ingress, egress, et cetera, load balancers, as well as shared resources if you've defined any. You can also see this row for idle and this column for efficiency. And I'll just briefly touch on the difference there. Idle is the amount of resources in your cluster not being provisioned to workloads. So basically how much headroom, how many more pods you can shove in before you start having noisy neighbors, things like that. Efficiency is the workload efficiency, that is the amount of utilization on a workload over the total amount requested, right? So if you've requested 10 CPU and are only using 5, your CPU efficiency would be 5. If you've requested 10 gigabytes of RAM and you're only using 5, your RAM efficiency would be 50%. 50% for the CPU usage, and you'd have a 50% overall efficiency. This efficiency is cost weighted. So based on the unit prices of CPU and RAM, we determine that weighting. Okay, so that's interesting, but obviously at the cluster level, we've already got that through the cost and usage report and other things. So let's drill down into workloads and groupings of workloads. So here we can see data sort of aggregated by namespace. I can pick a variety of different aggregations. We just saw cluster. We can go down to the controller level, for example, click through to actually look at individual pods in the controller, as well as like information for individual containers, as well things like how many CPU they're using, the hourly rate. This adjustment is data coming from the cost and usage report, so this is running on a savings plan or a reserved instance, and the total cost. We can also group by things. So not only are there Kubernetes level aggregations, there's also things like user-defined allocations, like product here is a mapping of labels. So we've got in this particular case, I believe product is defined as the label app, so we can look at views by product. We can also pick arbitrary aggregations, right? So we can just do label app, for example. We should probably get the same thing. I can add it here and get the same thing. If we go into settings, we can define a variety of labels that can be used for cost allocation, so you can bring your own kind of schema to this if you've already got one. Okay, cool. Let's kind of walk through how someone, an average like DevOps engineer might use this to troubleshoot and actually optimize workflows. So let's go here. Okay, so here I've prepared a cluster with some of our automatic right-sizing capabilities in. So we can see kind of three different, I've prepared 3 clusters, that is, and 1 KubeCost instance linking the 3. So we probably want to ask a question like, well, I don't want to optimize my dev clusters. We probably want to look at optimizing the workloads or products in the production clusters. So I can just actually do a multiple aggregation here and select a cluster as well as a product. So we can see that this workload or this set of workloads, a set of containers in KC Demo Prod Acme Fit is the most expensive, and it's only at about 17.9 cost weighted efficiency, right? So then how do I go in and look at Acme Fit? Well, I can come over here to the savings tab, look at right sizing container requests, look for the container Acme Fit. Okay, namespace. No, was it the namespace? What is the actual name of the container? I just lost it, sorry. I can go ask again. So let's look at controller, go down to, I can show you the filters here. So Acme star. Yep, so these are all the deployments and workloads in the Acme star namespace. I can jump down to the deployment. I can look at things by container as well. So we can grab the cart Redis container in the Acme Fit. And yeah, look at Acme Fitness. That was what I was missing there. So we can use the filtering to find where we are. We can look at the CPU usage, the CPU request. Here we can see that it's only using 0.9 millicpu and it's requesting 100. We just take our recommendation down to 10 to avoid throttling based on a 65% resource utilization. Similar ideas with RAM. We can look at the total usage of 4 MB, the RAM request of 100 MB, and notice the recommendation of 20 MB. We can also look at this over longer time periods of windows of 7 days, 30 days, etc. We can adjust the profile right between, so production is 65%, development we recommend a little bit less headroom, so you can look at workloads that way. And we can actually just go ahead and automatically implement these recommendations. And if you give the KubeCost controller the ability to do this, you can just apply it here. And yeah, so this will run over time and actually edit the manifest to lower the recommendations. Yeah, so that's the demo there. I'll hand it over to Vipin for some closing remarks.
All right, awesome. So let's switch the monitor. All right, so our goal today was to give you 3 different things that you could have in your toolkit to get better visibility into your EKS costs, as well as use that information to optimize and optimize your Kubernetes usage. So hopefully with that you're aware that we have cost allocation tags, we have Karpenter with consolidation, and then we have OpenCost and KubeCost. So one thing I do want to call out is that the enterprise features that Ajay just talked about are available to our EKS customers at no cost. So we announced that back in August 25th, if I'm right. So if you are interested in any of these capabilities, like feel free to reach out to us. I'll be at the AWS booth. Ajay will be at the KubeCost booth in the next few days. But I do want to talk about some of the things that we have on our roadmap. So with regard to the KubeCost integration, so we have an upcoming integration with Marketplace, which will allow you to deploy KubeCost into your EKS cluster with the same experience that you have for an EKS add-on today. So that's coming. We are also working on multi-cluster visibility and unified reporting that will allow you to aggregate all of your EKS cluster costs and have a single pane of glass view for all of the in-cluster costs. And with Karpenter, like I mentioned, it's open source, so feel free to go over to the GitHub repository and take a look. And if you have any questions, you can open an issue, and we'll definitely get back. So with that, I want to say thank you. So I really appreciate you making time for our session today. And both Ajay and I, will be available at the booth areas in the next few days, and look forward to talking to you. And have a great KubeCon. Thank you.
Thank you, everyone.
All right. Thank you for that session, Vipin. Thank you, Ajay. All right, folks, it's what you've been all waiting for. It's time for lunch. We're going to be taking a 1-hour break for lunch here. We're going to be coming back at 1:30. By the way, I just want to remind all of you that if you want to speak to any of the speakers, ask any questions, be sure to come to our booth tomorrow. It's booth D1. Lunch will be served in Hall E. That might not be listed on some of the material you see out there, but it is in Hall E. Lunch will be provided, and again, we're meeting here at 1:30. Thanks, guys.